Okay, so baking soda and vinegar, we know what both of those are. We know what they do when we put them together, but let's see a little bit about the science and the chemistry behind what's happening. So we're going to start off by talking about plain old baking soda. And so the chemical name for baking soda is sodium bicarbonate. That's the same sodium that you'll see in table salt, like sodium chloride. And bicarbonate, maybe you recognize the carbonate part in there, like a carbonated beverage. We'll talk about that in a little bit. But our formula for sodium bicarbonate is NaHCO3. We have sodium, that's Na. Bicarbonate is HCO3. And in fact, it's actually sodium is positive and HCO3 is negative, which means this is a cation and this is an anion. And so positive and negative, we know that means they're going to be attracted to each other. So my sodium is positive, my bicarbonate is negative. They are held together by their electric charges, so they kind of act like one thing. Okay, then we have vinegar. Vinegar is, the chemical name is acetic acid, and the formula for that is CH3COOH. Or another way you could write that is HC2H3O2. These have the same numbers of each element, they're just rearranged in a different order. Either way we look at it, we can see I have CH3, COOH, or maybe you want to think about it as HC2, and there's 3 H's over here and 2 O's, just writing the same thing in different order. Okay, so anyways, another important thing to know about vinegar is that vinegar is actually not acetic acid. Vinegar is acetic acid dissolved in water. And so that's why if you look at different bottles of vinegar, sometimes you'll see different percents, and that just means that it's a different amount of acetic acid dissolved in the water. Okay, so let's talk about our reaction. We've got baking soda. We know that's the NaHCO3. We've got vinegar. That's our CH3COOH. And we put them together, and then they react. That's our little arrow. And we end up with H2CO3, which we're going to call carbonic acid, and sodium acetate. That's NaCH3CO2. Okay, so that's cool and all right. So we already talked about baking soda and vinegar. Let's talk about these other two. So sodium acetate can be used to give a salt and vinegar flavor. And so if you think about that, that kind of makes sense. We've got the acetate from acetic acid from vinegar, and we've got the Na, like in table salt, that's sodium chloride. So we kind of have them both combined there. And so they use that in like potato chips sometimes. The other cool thing about sodium acetate is that it is used a lot in heating pads, like the ones where you kind of like pop the little button and then they get really warm for a few minutes. If you're like out in the cold and you want to warm up your hands or something like that. And that's a whole other story about why that happens. But basically, when it crystallizes, it releases a bunch of heat, and so that's the heat that you feel with your hands. Like I said, that's another story. Okay, so then carbonic acid. This one's pretty exciting too. This is the carbonation, that same thing, same chemical, same everything that we get in a carbonated soft drink. And it turns out it's also the carbonation in hard drinks. But the thing about carbonic acid is that it is not very stable, which means it doesn't like to stay as H2CO3 for very long. So we actually have two reactions here. This first one is the acid-base reaction, but then very quickly after that, we have the carbonic acid is going to break down or decompose, as we say. And so we have H2CO3, that's our carbonic acid, and it's going to react pretty quickly to give us CO2, which we know is carbon dioxide, and water, H2O. And so what basically happens after this is that CO2 forms gas bubbles. And those bubbles get trapped in the surrounding solution. And so that's why we kind of get the foam in when we mix our baking soda and vinegar, because we're making tons and tons and tons of CO2, and it just forms all over the place and gets trapped in the bubbles, and that kind of makes the foam. And it's all those bubbles are much, much less dense than the liquid that they were before, and so they give it much more volume, and that's why it kind of foams up and fills up the surroundings. And then the last thing about that is, if my little menu thing will go away because I moved my mouse, when those bubbles pop, that's what makes that fizzing sound that you hear, either when you make the baking soda and vinegar reaction, or if you like open up a bottle of soda and you hear the psst, that's a bunch of CO2 bubbles popping and then escaping out the bottle. Okay, so some other interesting facts that come in with this. If you keep something in a closed container, only so much gas can escape. So what this means for a carbonated drink is if you keep the cap on, those bubbles can't form because there's too much pressure, and so they'll just stay dissolved. And so that's why if you keep the cap on a drink, it will prevent it from losing its bubbliness, which we call going flat, right? So keep the cap on, it'll help keep it from going flat. But also, gases like CO2 are more soluble at cooler temperatures. And so what that means that if you keep your carbonated drink with the cap on in the refrigerator, that will make it take longer to go flat if you keep it in the fridge. So you probably already knew both of those, but here's a little explanation for why. Now the last thing is, how do we think that these facts would affect the baking soda and vinegar reaction? So if we did our baking soda and vinegar reaction and we put it in a sort of tight, solid container that's not going to let it expand at all, and we're going to keep it in a cold environment, what do we think is going to happen?